responsibilities today, and hopefully that'll make for an easier day for you. Right? So less respons. I mean, do you still trick or treat at this age?
Just go out and watch candy.
It's like a mixed reaction, right? Yeah, this is the age group from past experience where it's kind of like more of like a 50-50 split. Like it's less of a formal thing where like you're not just going around the neighborhood. What a lot of folks will do is just go to the mall and just wipe out one store and just call it a day, you know. So yeah, that's something. But anyway, I don't know. In my area, all the kids are going to like the local high school for trick or treating in the gym. So maybe that's a thing, right? Of course, they don't have that here.
There's trick or treating in the gym.
Not here.
They have houses.
But there are some schools that have that. Like White Plains High School has trick or treating in their gym, and so you know, like all the malls in my area. So. Yeah, there's that part of it, like the weirdness, and then also add to that the fact that it's supposed to rain all day. All right, so first move. Subtract the 3x. I'm writing the negative 3x in front because I'm going to put it in y equals mx plus b form. And so I figure that's just going to make life a little easier. I'm going to divide by the negative 2. So I'm dividing each part of my equation by a negative 2. What happens to an inequality when I divide by a negative?
The inequality sign switches.
The inequality sign switches. So 3 over 2x minus 2. All right, so now I want to plot that. All right, so y-intercept negative 2. Slope 3 over 2. Is this going to be a dotted line or a solid line?
It's going to be dotted.
Dotted. So up 3 over 2, up 3 over 2. Now the points that you plot could actually just serve as your dotting. So that's going to be good enough. It's frequent enough that you're okay. But if you want to, if you want to make it look a little more, just a little more, then, so make it a dashed line instead. You do have to label the line. So this is the line y equals 3x minus 2. All right, so that's not a mistake. That line is that particular location. All right, so now I just have to do my shading. All right, so some folks yesterday were a little iffy on the shading. And so one strategy that I use, and you don't want to do this every time because it could be a pain, is just draw a vertical line. All right, just draw a vertical line anywhere. You could just watch me do it, and then I'll show you what we're going to do with that vertical line. All right, so just draw any vertical line anywhere you want. All right, now the inequality that we're working with is y is greater than 3x minus 2. All right, the cutoff is this line. All right, which part of this vertical line would you say is greater than 3x minus 2? The part down here or the part up here? The part up here, yeah. So then you would erase the part that's irrelevant. Now, if you do that infinitely many times, what you're going to end up with is a whole lot of vertical lines, but only on the top half. All right. Now, like I said yesterday, this is something that the calculator is going to do for you. Now, I use for the display one of the old school calculators, just because this display doesn't actually work with the newer calculators. I had no idea just how user-friendly the newer calculators were, which unfortunately kind of gives a little bit of an unfair advantage to the folks who have the newer calculators, because there's a setting where it says flat out greater than. You know, you don't have to try to figure it out, you know. So when I'm typing in 3x minus 2, like the newer calculators have the setting where you could actually just select the inequality. And it'll change it, and so then you just graph it, and it's like, oh, geez. I mean, that's like, and my loaner calculators are all the old school calculators, so it's not even like I can say, well, for this upcoming test, borrow one of mine. It's not even like that. So you just have to know the upper if you want to use the calculator, that upper triangular, that means greater than, the lower triangular means less than. So remember, it's this distribution. Distribution. I like that word for some reason. It doesn't apply in this case though. This is greater than, because the arrow is kind of pointing to the right in the same way the greater than symbol would point to the right. And then this is a less than symbol. People have said, the mnemonic devices are helpful. So, I mean, I've been working with this long enough so I don't even think about it. But people have said that as they were drawing this symbol, they're like, okay, I made an L. L like as in less than. Right? So this symbol here, this triangular, is an L-shaped triangle. So that's helped them remember. All right? Whatever works is going to be fine by me. All right? But bottom line is you got to get the shading right. So whatever it takes, short of cheating. All right, now the linear inequality word problem. Marie sells tacos and burritos from a food truck at the farmer's market. She sells burritos for $3.50 each and tacos for $2 each. She hopes to earn at least $140 at the farmer's market.
What?
I know. She wants to make a killing at this farmer's market. Create a linear inequality that represents the solution to this problem. Let x equal, so we don't have to write the let statement. Let x equal the number of burritos that Marie sells, and let y represent the number of tacos that Marie sells. Now, like I don't want to go too crazy with this, but I am noticing through assessments that less and less people are forgetting to write their let statements, which is a good thing. All right, so let's get it to a point where nobody's forgetting to write them. In this case, you don't have to write them because they already gave it to you. All right, so the burritos are $3.50 and the tacos are $2 each. Now, something, and this has come up a few times, there's not too many people that are having issues with this, but there are enough that I feel like it's worth it to go over. When you're talking about cost, what you're talking about is unit price times the number of units. All right, so if I told you that one book cost $5, but you're gonna need to buy 10 books, how much are you gonna have to pay? 50, because what you did intuitively, without knowing this rule, is you took the two numbers and multiplied them together. All right, so what we're doing here is we're looking for the cost for the tacos and the burritos. The burritos are $3.50. That's the unit price. That's how much one taco would cost. Multiply that by the number of tacos. I'm sorry, burritos. I like tacos more than burritos, so it's on my mind. What day is today? Wednesday? Thursday? Oh, it is Taco Thursday. Okay, cool. That's what I'm thinking. No, you're out of your mind. You're out of your mind.
Taco every day.
Yeah, I mean, that's the right answer.
Yeah.
Like, taco any day, but in the Can household, it's always Taco Thursday. Yeah, well,
What about Taco Week?
LeBron James is not Mr. Can. Taco a year.
Tacos for you. No other food.
I went through an entire week and I made 7 different variations on tacos.
Have you been to the truck before?
What's that?
Is it truck?
Truck?
Yeah.
No. Is it like a food truck?
No, it's called truck because it used to be a truck stop. Now it's a Mexican place.
Oh, really? It's really good? I'll try it. I like trying new Mexican places. All right, so $2 for each taco. Now, she hopes to earn at least $140. At least. All right. Now, it's all on the back board, but at least is our greater than backboard, back wall, greater than or equal to. All right. That's $140 or more. All right. Now, you do have a clue where if you accidentally put an equal sign here, when you get to the question in B, or the prompt, you do have a clue that you need an inequality because it says it flat out. All right. So we have to graph this, and we're going to use the same strategy we used for the previous question. We're going to solve for y in terms of x. All right. So it says graph your inequality on the coordinate plane, then shade the half plane that contains all possible solutions to this problem, and then determine if this number is in a solution, right, in a solution set. Now, the numbers might get a little crazy, but we got to think about the fact that we don't need negative x's or y's at all right? Because how do you have a negative burrito? Well, actually, it's kind of disgusting, but I guess you can have a negative burrito.
An anti-Rito.
No gracias.
Let's say it didn't agree with you. It came back out. Yeah, if you had a bad burrito, I suppose it could come out the other way. So the question would be, which technique would be the most appropriate way to create the graph? Would it be most beneficial to graph it by setting it equal to y in terms of x, or is it better to find the x and y intercepts? And that's the question that you yourself need to answer. All right. So, because one way or the other, we need to come up with a shaded area that's only going to live in the xy, in the first quadrant of the xy plane. All right. So, since you're kind of accustomed to solving for y in terms of x, I'll just do that. All right. So 2y greater than or equal to negative 3.5 x plus 140. Then divide by the 2. Y is going to be greater than or equal to, force of habit, negative 1.75 x plus 70. All right. Calculator is going to be helpful here because I have a y-intercept of 70. I can plot that easy enough. I'll just go by tens, I guess. You can go by fives if you want to use more of the graph. I still think finding the x-intercept is going to be the better way to go, because if I didn't, then I'd have to count a slope of negative 1.75. Not crazy. You know, I could figure that out in fraction form, but on a scaled graph, it's not the easiest thing in the world. So what we can do is go into our calculators, type in the function that we have, negative 1.75, negative 1.75x plus 70. I'm just going to keep it as an equal sign just so I'm on the same page with most people. All right. If I create the graph, it's going to give me a whole lot more than what I need, but it might give me a sense of when it's going to hit the x-axis. So, you know, you could try to do that, and you'll see. You know, you'll have to do a zoom, but you'll see it's going to be in the neighborhood of 40. It's just a question of, is it going to exactly be 40? All right. So the best way to handle that is to go into your table and start scrolling. You could see that the y values are decreasing. We need the y value to be equal to what in order to find the x-intercept? What does the y value have to be equal to? For the x-intercept, the y value has to be. In order for a point to be on the x-axis, the y value has to be equal to 0. All right, so find the x value that has a y value equal to 0, and it'll be 40. So you can kind of just tuck it in here as another scale of 10, scale factor of 10. It's a tight little graph there, but you can scale it any way you want as long as it fits on the grid. So if you went by 5s, that would have been okay also. Solid line, because it involves inequality. Bless you.
Bless you out.
All right, so this is my shaded region. Oh, greater than or equal to. Oops. All right, because we want at least. So anything that's not in this interval, in this little area here, would be the correct answer. So we want to shade. Look at this high quality shading. All right, I'm keeping mental note of when the shading stops. I guess I didn't have to keep mental note. I have a counter. That was about 30 seconds. All right, so this is my solution. Yeah, by the way, that's not good. It's definitely not good. All right. So 20, 49.5. Is that a solution to the inequality?
Yes.
Yes?
Yes.
Yes, and we would say, but really kind of just barely, right?
Yeah.
So it's going to be like right about mirror. Yes. The reasoning part is easy. Yes, falls in shaded region. All right. Now this is the number of burritos and number of tacos. So it's kind of like, well, how do you have 49 and a half tacos? Well, maybe they gave a discount on one of them. You know, if maybe somebody had a discount card or something like that, and they got half off. You know, so yeah, some sort of deal, some sort of promotion. So you don't want to think about it as you're giving a person half of a taco. What you're doing is you're charging them for half of the value of a taco. All right, so that's the important piece here. But that's really all we're looking for. And again, look at my high quality shading. It's not like it's not like you're going to get bonus credit for having a beautifully shaded region. I mean, I showed you my graph from before. Oh, I already erased it. But I showed you my graph from before on the calculator, and it was beautiful. All right. That's computer generated. The reality is, in real life, if you were to create graphs, you're not going to do it by hand. Like if you're in the real world and you needed to create a presentation for, some sort of business proposition, and it involved graphs, you're not. Let's just put it this way: if you wanted to make a proposal and you came in with hand-drawn graphs, your proposal's getting denied. All right, bless you. So you're going to be using technology. So when it comes to creating graphs now, we just want to get the job done. That's all we really care about. All right, so bare minimum in terms of effort. So, which really kind of stinks because I know it's sort of drilled into your heads in previous years that if things weren't just so that you were going to lose credit, but it's not like that. All right, it can't be like that. It's not practical. All right. So your responsibility is to complete through page 32. All right. So that's going to be for Monday.